what I'm going to talk about right now. I'm going to go over our system a little bit and go over the background, the SSOC, the step function, sign response, root locus, and then I'm going to turn it over to Tim to talk about the proportional controls, P-only controllers, and then also the PI controllers. And then he will conclude the presentation. Here's a block diagram of our system. As you can see right here, our input is percent, and then it goes into the system and we get a voltage output. Here's a picture of the 5 horsepower motor on the left with the DC generator here on the right, and then this is the lights that give a visual demonstration of the output. Here's our SSOC. If you remember from last week, I presented this as well. I'm going to point it out again. It's not linear. We divide it up into 4 different regions because we have 4 group members. The first region, which is mine, is from 0% input to 50% input. As you can see right here, it has a very small gain for how much percent input it gives. And then the next region is from 50% input to 70% input. And then from 70% input to 80% input, and then 80 to 85. Next is the step response. This is one from the 0 to 50%, a step up, and these are the change in the delta M is the 50%. That's the input, and that gives us a change in C of about 2.5 volts. So a very small gain. And then here's the tau and the T naught. Here's another example of a step-up response, one that looks a little bit more exciting, interesting. This is from 50% to 70%. As you can see from the last graph that I showed you, it stepped up rather quickly, but right here, if you look, it takes a little bit longer for it to step up, and therefore we have a much bigger tau. So here's a graph of our gain for the step ups and step down for our system. And here's the dead time. If you look over here, you'll see that there are some different, I guess, values. Most of those differences come in the first region that I talked about that had very little gain, and then also in the second region that had a sharp curve up and a high gain towards the end of that region. In this one, we can see that the dead time takes place. There's a larger dead time in that lower region. With the time constant, tau, this one right here, this is actually goes off the chart. If you remember that I pointed out that one actually went up to about 15. But everything else was relatively small. This one did jump up above 1 second. And now for the sine waves. There's a graph of our sine wave. And the Bode diagrams. This red line is the modeled, and then the blue diamonds are from the experiments. And as you can see, we matched up as close as we could, but there's a little bit of difference in the shape of the curve there. This is from 80 to 85%, from 70 to 80%, 50 to 70%, and then from my region, I was actually out with my baby being born during that week, so I did a different thing. I didn't do the Bode, I did a relay response. So this is a graph of my relay response, and it gave me some of the same information. So these are from this is the results from those Bode diagrams, and then also from my relay response results. And because the shape of our SSOC, that first region had a very small gain, and so from the relay response that I got compared to their Bode results, it was a much smaller gain, which is what we expected after seeing the SSOC. There's the tau from the Bode results, and then my relay response results. The T naught. And then we move on to the root locus. This is from the 0 to 50%. These numbers are based on my step response. The gain, the tau, and the T naught. And this is from the 50 to 70%, and these are based on the Bode model that they got those numbers from. So 70 to 80%, and 80 to 85%. And so here's a graph showing the overall comparisons with our system's Kc values as it increases. We have the different regions right here. And now Tim is going to start talking about the proportional component.
We wanted to show you an example